So the first guide, if you're kind of stuck for solving for y, we're going to move the x first. So subtract the 2x. Right? That will give us 3y equals negative 2x plus 10. So we're rearranging the equation. We want the same equation, but just y by itself. And then one more step. Divide everybody by 3. Right. So y equals negative 2/3 x plus 10 over 3. Right? So we're just rearranging our equation. Make it mx plus b. That's really our goal. And the reason why that's our goal for today's lesson is we're going to solve graphically today. So graphing two lines, two linear systems, or one linear system, two lines, and finding their intersection. And how do we graph lines? Well, we use our y-intercept and our slope. And so we have to be able to put it in y equals mx plus b. The next equation, what was your first step? Nancy? Okay, you could either move the 10x and the 5, or the 2x and the 5, or we can move the y. Doesn't matter. If we move the y, we're eliminating a step. We have 2x minus 5 equals negative 10y. And Miriam, what's our next step? By negative 10. 2 divided by negative 10, what does that reduce to, Amy? That reduce? Yeah, what can we divide both those numbers by? 2. So it becomes negative 1/5 x, and negative 5 divided by negative 10. What happens when we divide two negatives? Positive, and that reduces to 1 over 2 equals y. And it doesn't matter which side y is on. It could be on the left side or the right side. It kind of seems backwards to have it on this side, but it really doesn't matter. All right, next guy, getting y by itself. Who's hanging out with y right now? 2y. We have 1/3, right? Hanging out. So first step, Vance. Want to get y by itself. Who do we have to get rid of first? We want y by itself. Before we can divide, we have to take care. Okay, I'm sorry. Okay. No, we don't have to get rid of the fraction. Subtract 1/3. Subtract 1/3. It's a tough one. It's a little different than what we're used to seeing. It looks, we usually don't have these fractions in there. So x minus 1/3 equals 2y. Then what? Divide everything by 2. Now, dividing.
It's the same answer when you multiply everything by 3.
Yes, you do. Yeah, you'll get the same answer if you want. It will be. How do we write x divided by 2 with a coefficient? 1 over 2 x. Right, that 1 was with the x. It becomes 1/2 x. And then negative 1/3 divided by 2. You can either use your calculator, or we can divide fractions by numbers. How do we divide negative 1/3 by 2? Remember our skills from back in the day? Put it over 1 and then? No, not for division. Multiply by the reciprocal. Yeah. Multiply by this. And then, so negative 1 times 1 is negative 1. 3 times 2 is 6. So minus 1/6. On your calculators, you could type that in as well. So negative 1/3 divided by 2 is negative 1/6. Okay, and that equals y. Very good. So those are tough ones. I threw in tough ones because that's the prereq skills, right? So if we can rearrange for y equals, you're good for today. Bless you. That's a lot of sneezes. Okay, so let's go through solving graphically. The first of 4 lessons on how to solve, find the intersection. So one way is graphically. So our first step when we want to graphically solve is put all equations in, Jordan, y equals mx plus b, or y equals form. Why would we want it in that form? Jordan? So we know the y-intercept, and we know the slope, so we could plot the line. Beautiful. So let's do that. I like to number my equations, something we'll do all unit. So equation 1, is it good to go? Yes, it is. What is my slope? 2 is our slope, right? 2 over 1. And what's my y-intercept? That was my slope. Negative 5 is my y-intercept. Oops. Negative 5 is my y. Okay, my b value. Okay, so let's plot that. Y-intercept of negative 5. It's in 10 by 10 grid. It's a magic pen. Yeah. Okay, and slope is 2, or 2 over 1. So what direction are we moving? Up to right 1. Up to right 1. And so forth. Make a bunch of points. And then what are we going to do with those points? Connect them. This is where having a ruler for today is going to be helpful. Or just roughly sketching is fine too. Okay, second guy. Is he ready to plot? Not yet. Can you please rearrange him for mx plus b? First step. Somebody want to tell me the let's do it with Sarah. What's our first step for making y by itself? What did you do first? You subtracted 9? And you made this side equal 0? And then you brought the y over there? Yeah, that will work. What else could we do? Yeah? Jaden? Subtracted 2x would work too. You'll still get the same answer, Sarah. I'm just going to subtract 2x. Okay, yeah, just take an extra couple steps. And then last step is divide by 3. Good. Okay. So that gives us y equals negative 2/3 x plus 3. First thing we plot, 3, the y-intercept. And then our slope is negative 2 over 3. So down to right 3. There it is. Down to right 3. Uh-oh. Uh-oh. Yeah, little light show there for you. Up to left 3. Okay, so grab your ruler. Let's connect these points. So where's my intersection point? What point is that, though? X is 3, comma, y is 1. So our solution is 3 and 1. That's the point on both lines. That's the one they share in common. So easy. So what's a system of equations to review? Well, let's change this. What's a linear system of equations? Let's take it a step further. What's a linear system of equations? If it's 2, yeah? So a system has 2 or more equations with 2 more variables. If it's linear, how many variables are we going to have? The same 2, x and y, and how many equations do we have? 2. So a linear system of equations has 2 equations with 2 variables. And those variables are usually x and y, right? And the equations have to also be degree 1. So 2 degree 1 equations with 2 variables. Yeah, so the whole unit, we're always making two equations with two variables. Every time. Two equations, two variables. What does it mean to solve a system then? Find the intersection. The point that's in common with both. The point in common with both lines. So it's a point that's on both lines, and they share. Easy enough? So on the next page, there's two graphs. I'd like you to try the first one on your own. If you get that one, it works out and everyone gets it, then we will skip the second one on that page. So can you please try to graph both of these? Okay, so I'll graph both of these, find the intersection, and if it goes well, then we can skip the next one. This one. So equation 1, we're going to rearrange it as negative x plus 8. Okay, so what in this first equation, what was my y-intercept? Which one's the y-intercept in the first equation? The constant. The constant is 8. So your y-intercept was 8. The slope in this equation is what, Michael? Yeah.
3/2.
The first one?
Oh, sorry. I was thinking the second.
Yeah.
1 over 1. Negative 1 over 1.
Negative 1, and we put it over 1. So now we're going to move. What direction?
Right.
Down 1, right 1. Down 1, right 1. Okay, so that keeps going. You should draw that line. So connect that. Oh my. Let's try this again. Ooh, that's really bad. Shh, guys. Okay. Nancy. Second equation. 14 equals 3x minus 2y. First step. Move x. So how do we move it? Minus 3x. So we get negative 3x plus 14 equals a negative 2y. Then divide by negative 2. What happens when we divide negative 3 by negative 2? Positive 3 over positive 2x. What is 14 divided by negative 2? Minus 7 equals y. So in this case, what's my y-intercept? The constant is negative 7. My slope is 3 over 2. So first we plot the y-intercept of negative 7. And now what direction are we going to move? Up 3, right 2. Up 3, right 2. Up 3, right 2. Up 3, right 2. My graph is not the best. What point do they have in common? 6 and 2. Now this problem, so our solution is 6, 2, but it also wants us to check the answer. Don't forget to check when it says check. When it says check, where do we plug in our answer to? Yeah? Equations. And we always use our original equations whenever we check. Because what if we made a mistake in rearranging? So we always check with our original equation. So y equals 8 minus x, and 14 equals 3x minus 2y. So we're going to plug in our x and y solution. In the first equation, what's the y? What was our y in our solution? 2 should equal to 8 minus, what's our x? 6. What's 8 minus 6? 2. Left side equals right side. Okay, plug in my x again. 3 times, what's the x? Remember x comma y. So 6 minus 2 times 2. What's 3 times 6? 18. What's 2 times 2? 4. So 18 minus 4 is going to give us 14. That's our solution. Okay. How was that? Good. Do you think we need to do the next graph? No. Okay, so let's go to the last question. Okay, so what I'd like you to do with this last question is start by writing the equations. I want you to give it a shot. And then we'll go over it. So in A, write the 2 equations for this linear system. Remember, a linear system will have how many equations? 2, and how many variables? 2. So the first thing you ever want to figure out is which variables are we using. So I'll read it with you, and then I want you to try making the equation. To visit the Head Smashed and Buffalo Jump Interpretive Center near Fort Macleod, Alberta, the admission fee is $5 for students and $9 for adults. In 1 hour, 32 people entered the center and a total of 180 admissions was collected. What are the 2 variables? What are the 2 unknowns in this situation? Students. What about students and adults? How many? So let's all use the same variables. So S will be the number of students and A will be the number of adults. Now we can always use X and Y as well, or you can use S and A. Let's start with S and A. So I'd like you to try and make the equation on your own. Okay, so you should have had one equation as A plus S equals 32. And then all our money goes together. 5 times the number of students plus 9 times the number of adults equals 180. Or you could go 9A plus 5S, same thing. Okay? So we're going to solve this graphically. I'm sorry that your graphs aren't very clear. In order to solve this graphically, we basically have to isolate one of the variables because we want to make it y equals. If there is no y, that's okay. We'll just choose a variable as our y. So which variable do you want to isolate for, A or S? Doesn't matter? No? Okay, so let's start with, I don't know, A. Doesn't matter though. Okay, a couple people said A. So if we're going to isolate A, that means A is going to be which variable? Y. We're isolating A. That means Y is A, our adults, in our graph. So start with the first equation. A plus S equals 32. We want to get A by itself. Minus S. And our equation becomes A equals minus S plus 32. Okay, so that means our students is our X, right? Number of students. We need a y-intercept all the way up to 32. So we're going to go up by 2s to the best of your ability, okay? I'm sorry that your graph is not the greatest. So what I'll do every 2 spots is 4. So we need to get all the way up to 32. So 4, 8, 12. And if you have to roughly sketch it, okay? I'm so sorry that didn't photocopy nicely. 8, so 20, 24, 28. We'll do that for both parts of the grid. 30, I know, I I'll have to make it darker next time so that when it photocopies, it's not so bad. And then this guy, again, 4, every 2 is 4. So if you have to roughly put points on there, that's okay. 20, 24, 28, 32, and 36. Yeah, you can do that. So our y-intercept is, if A equals negative S plus 32, y-intercept is 32, the constant. Now, what's our slope of this equation? Coefficient of the S. What's the coefficient in front of S? We just have a negative number there, negative sign. negative 1. It's really a negative 1. And so negative 1 over 1. Now our scale is up by 2's. So going down 1, right 1 is the same thing as going down 2, right 2. Because the scale is the same. So it works out nicely. So if we continue this pattern down 1, right 1, what's my x-intercept going to land on? Do we know? We keep going with this pattern. Down 1, right 1 from 32. Where are we going to land? 32. 32, yeah. So 32 and 32 are our intercepts. Which makes sense. If we have no students and 32 people came in, then all of them were adults. Or if we have no adults and there's 32 people, then there'd be 32 students. Okay, so connect that line. Well, technically, do we connect that line? No, number of. Now we're looking for intersection, so connecting it is going to be helpful to solving this problem. So I'm just going to connect it in gray, if that's okay. So it's just roughly there, but not there. If you have a pencil, just go lightly with your pencil. Okay, we need that for our intersection point to the best of our ability. Properties. Let's just go like this. There we go. Okay, next equation, isolating A. So the other equation was 5s plus 9a equals 180? Yes. Okay, so get A by itself. Minus 5s. So 9a equals negative 5s plus 180, and then divide by 9. Yes, that's true. That's where you can replace them with x and y if you want instead. A equals negative 5 over 9s plus, what's 180 divided by 9? 20. So what's also helpful is when we interchange these variables instead of x and y, I like to make a legend for myself. So I said A is actually y and s is actually x, just so I remember which one's my x and y, especially if you were graphing this on your calculator. Now in this guy, who's the y-intercept? 20. So y-intercept's 20. Now we have a difficult task ahead of us, because what's our slope? Negative 5 over 9. Now we are plotted with even numbers instead of odds. So what can I do to this ratio to make them even numbers? No. An equivalent ratio with even numbers. Multiply top and bottom by 2. Is negative 10 over 18 the same as negative 5 over 9? Yeah, that's going to be a lot easier to plot, because going down 10, right 18 works well with my graph. So starting off where I left off right here, down 10 would bring me to 10, and then right 18, right here. Down 10, right 18. That works a lot better with my graph. And then down 10, so that would bring us down to 0. Right 18 brings us to 36. So we do cross. So again, we'll draw a line. I'm just going to roughly draw the line because I need to find that intersection point. Now it shouldn't be going through, it should be like right over here. Should be right there, kind of in the middle. Yep. So the slope was negative 5 over 9. So to make it nicer, because it's hard to go down 5, right 9 when all our numbers are even. So I just doubled the top and the bottom. So that's equivalent slope is negative 10 over 18. Okay, so it's really hard to see, especially if you're not using very bad graph. Your graphs are not very nice. But we should be halfway between 26 and 28, which is 20 7.
So what's the intersection?
Halfway between 26 and 28. So the intersection, and here it's between 4 and 6, 5. So here our point is 27 comma 5. So 27 what? Adults or students? 27 students and 5 adults. Now how would I check my work here? Sub it into where? Our original equations. So let's just kind of work this through really quickly together. We had 7 and 5, 27 and 5. So with my calculator, I'm just going to do a quick check. Does 27 plus 5 equal 32? Yes. 5 times 27 plus 9 times 5 should equal $180, and it does. So it's always good to check our solution, even if it doesn't tell us that we have to, because why not check if you're right or not? Okay, so that's it for today's lesson. So it's solving graphically. Your homework, did everyone finish this page? Yeah? Your homework is here. It's really important that you use graph paper to solve number 5 and 7b. If you need graph paper, I have extras on the side table. Okay, do you need me to go back?